In this video, i-discuss lang natin yung iba pang mga theorem on limit of a sequence. So meron akong 4 na theorems dito pero isa lang yung ipoprove ko dito. So number 1, limit of 1 over n raised to p where p is greater than 0 as n approaches infinity is equal to 0. Then for number 2, limit of a raised to n as n approaches infinity is equal to 0 if the absolute value of a is less than 1. And for number 3, limit of n raised to 1 over n as n approaches infinity is equal to 1. And the last one, limit of a raised to 1 over n as n approaches infinity is equal to 1 for all a greater than or for any a greater than 0. So isa lang yung ipoprove natin, yung madalas na ginagamit. Ito yung number 1, yung 1 over n raised to p for positive p. Okay? Then sinama ko lang tong 2, 3, 4 kasi pwede nating baka magamit lang natin siya sa mga susunod nating discussions or sa mga example or sa exercises na ibibigay ko sa inyo. So ito yung ipoprove natin. Let's prove number 1. Okay, so for our proof, ang gagawin lang natin, ipoprove lang natin yung limit nito ay equal sa 0. Okay, so convergence, by definition lang ng convergence sequence yung gagamitin natin. So una, ang gagawin natin, dapat makahanap tayo ng natural number. So for our discussion, so dapat given positive epsilon, makahanap tayo ng natural number n such that for all n greater than or equal to n, dapat yung distance ng 1 over n raised to p minus 0 is less than epsilon. Okay? By definition of convergent sequence or limit of a sequence. So, yan yung gagawin natin for discussion. Hanapin natin yung natural number n. So, paano natin gagawin yan? So, consider natin to. So, consider the absolute value of 1 over n raised to p minus 0. This is equal to absolute value of 1 over n raised to p. Okay? And this is the same as 1 over n raised to p. Tama? Kasi yung n natin ay natural number at yung p natin ay positive. So this, pwede nating alisin na yung absolute value. And this is less than epsilon. Okay? Now, i-ano lang natin, i-cross multiply lang natin or hindi siya totally cross multiply. Pagpalitin lang natin ng pwesto to. Ibig sabihin, ang gagawin ko dito, magmumultiply ako both sides ng n raised to p over epsilon. So kapag nagmultiply tayo both sides ng n raised to p over epsilon, so ang mangyayari dyan, this implies 1 over epsilon less than n raised to p. So hindi mababago yung symbol kasi positive naman yung minultiply natin. Positive tong n raised to p, tapos positive din tong epsilon. Okay? Now, magmultiply tayo, or hindi pala magmultiply, mag-ano tayo, i-ano natin siya, 1 over p. Okay? 1 over p. So, ano bang magandang term dyan? Pth root, no? Pero naka-fractional exponent lang ginawa ko. Kasi ang target natin, ma-cancel to, matira na lang n, no? So, this implies 1 over epsilon raised to 1 over p less than ito para ma-cancel yung exponent at matira na lang yung n. Okay? Or n greater than 1 over epsilon 1 over p. So since n greater than 1 over epsilon raised to 1 over p, so pwede nating piliin yung natural number n to be greater than this real number by Archimedean property. Kasi according to Archimedean property, again, for any real number, palaging may mas mataas na natural number. And let's say yung mas mataas na yon ay yung ating big N. Okay? So, choose big N to be greater than 1 over e raised to 1 over e. Okay? So, yan. Proceed na tayo sa proof. Okay. For our proof, let epsilon be greater than 0 and choose n to be greater than 1 over epsilon 1 over p. Okay? Then, for all n greater than or equal to n, dapat mapakita natin na yung absolute value ng 1 over n raised to p minus 0 less than epsilon. So dapat yun yung mapakita natin. Okay? N is greater than 1 over epsilon raised to 1 over p. Okay? Since yung n natin, large N, is greater than 1 over epsilon 1 over p. So ibig sabihin, sigurado tayo na for any n na larger or equal dito sa n is larger than 1 over. Okay? Now, so reverse lang yung ginawa natin kanina sa discussion. Mag-ano tayo, by the way, this implies n greater than 1 over epsilon is to 1 over p. So kahit ano naman ano mo dito sa 1, okay lang. Kasi hindi naman to 0. Sigurado tayo na hindi 0 to kasi yung p ay greater than 0. Okay? Now, maglagay tayo ng exponent both sides ng p. So dito maglagay din tayo ng p para makancel natin to. Ang mangyayari, this will be n raised to p greater than, cancel to, magiging 1 over epsilon na lang. Okay? And pagpalitin din natin, so reverse yung process na ginawa natin kanina. So magiging ano siya, this implies epsilon greater than 1 over n raised to p. Okay? Or para makita nating maigi, 1 over n raised to p less than epsilon. Okay? Now, since yung 1 over n raised to p ay equal sa 1 over n raised to p minus 0, and this is also equal to the absolute value of 1 over n raised to p minus 0. Okay? Kasi sigurado tayo positive to. Tapos ito, wala namang naging epekto tong minus 0 na yan. Tapos pwede nating lagyan ng absolute value kasi positive naman yan by definition of absolute value. So ibig sabihin, this implies that absolute value ng 1 over n raised to p minus 0, which is equal to 1 over n raised to p, which is yung 1 over n raised to p ay less than epsilon. So ibig sabihin, ito ay less than epsilon. Okay? For all n greater than or equal to n. Okay? So therefore, yung limit ng 1 over n raised to p as n approaches infinity is equal to 0. And this is done. So i-apply naman natin yung theorem na to, yung theorem 1, para i-prove naman yung ibang limits. Okay, so let's have number 1. Show that limit of n minus 5 over n squared plus 7 as n approaches infinity is equal to 0. So dito, hindi muna natin gagamitin yung definition ng convergent sequence. Okay? So ang gagamitin natin dito ay yung theorem na prove natin kanina. Ito yon, yung limit ng 1 over n raised to p as n approaches infinity is equal to 0. So i-apply natin siya mamaya sa ating proof. So hindi na ako maglalagay dito ng discussion kasi nga hindi ko nagagamitin yung definition. Okay? So dun muna tayo diretso na tayo sa proof. Okay? Now, yung limit ng n minus 5 over n squared plus 7. So hindi ko na isusulat yung n approaches infinity. So basta understood na natin yan. This is the same as limit, mag-divide ako dito ng n squared sa both sides, yung may highest na exponent, n squared. So n over n squared minus 5 over n squared all over n squared plus 7 over n squared. Okay? Now, this is also equal to limit ng ito ay 1 over n minus 5 over n squared over ito ay 1 plus 7 over n squared. And applying theorem 1, kapag i-apply natin to, yung theorem na yung limit ng 1 over n raised to p, basta yung p ay positive, ito daw ay 0. So kapag in-apply natin yung limit dito, okay, so itong limit ng 1 over n, this is 0, no? So this is equal 2. By the way, bukod sa in-apply natin yung theorem na to, yung prove natin kanina, in-apply din natin yung operations on limit. So, ito yung para sa addition or subtraction. Tapos, in-apply din natin dyan yung multiplication. So, hindi lang gaanong kapansin-pansin, no? Pero, nag-apply tayo dito ng operations on limit. So, tapos, i-apply natin sa bawat isa dito. So, limit nitong 1 over n, that is 0, minus limit nitong 5 over n squared, that is also 0, over 1 plus 0, yung limit nito. And this is equal to 0, which is ito. Yung ano natin. Okay? So, ibig sabihin, yung limit nito ay equal sa 0. At yun yung pinakita natin. Okay? Nag-apply tayo ng operations on limits, tsaka in-apply natin yung prove nating theorem kanina. So, this is done. At kung mapapansin nyo, para siyang solving na lang. So, bukod sa kaya nating i-prove na yung limit ng isang sequence ay equal sa value or equal sa isang real number, pwede rin nating hanapin yung limit ng sequence kahit hindi pa binibigay kung ano yung real number na yon, kung sakaling convergence sequence yon. Okay? Applying this theorem 1. Okay? So, itry natin, maghahanap naman tayo ng limit. So, hindi muna tayo mag-prove. Okay, let's have another example. Okay, so let's have example number 2. Find limit of n cubed plus 6n squared plus 7 all over 4n cubed plus 3n minus 4 as n approaches infinity. Okay, so for our solution, so limit ng n cubed plus 6n squared plus 7 over 4n cubed plus 3n minus 4 as n approaches infinity, this is equal to, so ang una natin gagawin, i-divide natin yung numerator tsaka yung denominator by n raised to p, where p yung highest exponent nito sa dalawa. At yung highest exponent ay yung 3. Okay? So, i-divide natin by n cubed. So, this will be equal sa limit ng n approaches infinity ng what is n cubed divided by n cubed, that is 1, plus 6n squared divided by n cubed, this is 6 over n, plus eto 7 over n cubed, all over eto divide sa n cubed, that is 4, plus divide natin sa n cubed, that will be 3 over n squared minus 4 over n cubed. Tapos i-apply natin yung theorem na prove natin kanina. So, kapag kinuha natin yung limit nito, tsaka to, pati ito, tsaka to, lahat yan ay 0. So, magiging 1 plus, ito ay 0, plus 0 over 4 plus 0 minus 0. Okay? And this is equal to 1/4. So, yun yung limit nito. Okay? Napakadali, di ba? So, ganun kalakas yung kapangyarihan ng theorem na prove natin kanina. Okay? So, punta naman tayo sa isang napakahalagang theorem din sa limit of a sequence, yung squeeze theorem. Squeeze theorem or sandwich theorem. So, for example, we have 3 sequences, x sub n, y sub n, and z sub n. 3 sequences of real numbers such that y sub n is greater than or equal to x sub n, but less than or equal to z sub n for all natural number n, and that yung limit ng x sub n, ito yon, is equal to limit ng z sub n, ito yon, is equal to L. Then, yung y sub n, yung nasa gitna, sequence y sub n is convergent, at yung limit ng y sub n ay same dito sa limit nila, which is equal to L. Okay? So, kaya siya tinawag na sandwich. Kumbaga, ito yung dalawang, yung nasa taas, tapos yung nasa baba, tapos ito yung parang palaman nila. Okay? Yung y sub n. Okay? Kung saan nag-a-approach yung dalawa, yung nasa taas tsaka nasa baba, doon din mag-a-approach yung nasa gitna. So, para maintindihan natin, so ganito yung itsura niya. Let's say, ito yung ating L. Okay? Kung nandito yung sequence na z sub n nasa taas at nag-a-approach siya halimbawa sa L, so let's say ito yung z sub n, tapos yung yung x sub n naman nasa baba at nag-a-approach din siya sa L, so ito yung x sub n, then yung y sub n, which is yung palaging nasa gitna, so, let's say ito, mag-a-approach din siya sa L, ating y sub n. Okay? So, ganun yung itsura ng ating squeeze theorem or sandwich theorem. So, ang gagawin natin, ipoprove muna natin yung theorem na to. Pagkatapos ay magbibigay ako ng isang example kung paano ginagamit yung theorem na to. Okay, for our proof, given positive epsilon, so by definition of limit of a sequence, may mag-e-exist daw na natural number n such that for all n larger than n, yung distance ng x sub n and L becomes smaller than epsilon, and same din sa z sub n, smaller din sa epsilon kasi pareho lang naman sila ng limit which is L. So ang kailangan nating mapakita, yung dapat yung absolute value ng y sub n minus L ay less than epsilon. So ito yung goal natin. Okay? For all n greater than or equal to n. Okay? Now, since yung x sub n ay less than or equal to y sub n, less than or equal to z sub n for all n element of set of natural numbers according sa definition niya, ito yung ating hypothesis. Yan. Okay? Now, this implies kapag nag-subtract tayo ng L, real number L, sa lahat ng sides na yan, so magiging ano siya, x sub n minus L less than or equal sa y sub n minus L less than or equal sa z sub n minus L for all n element of set of natural numbers. Now, since yung absolute value ng x sub n minus L less than epsilon, so sigurado tayo na yung x sub n minus L ay mas malaki doon sa negative epsilon. Okay? So imagine nyo na lang. Sige, papakita ko na rin. So kapag i-apply natin yung property ng absolute value, so hindi ko siya isasama sa proof ha. Pakita ko lang yung application ng nung property ng absolute value. This is negative epsilon less than x sub n minus L less than epsilon. Okay? So makikita nyo, yung x sub n minus L ay greater than negative epsilon. At kung mas malaki dito sa x sub n minus L, yung y sub n minus L, sigurado tayo na yung y sub n minus L mas malaki dito sa negative epsilon. Okay? So this implies negative epsilon less than or equal sa y sub n minus L. Okay? And this is less than or equal then dito sa ating epsilon. Okay? Kasi ito yung epsilon. By the way, mas accurate kung i-imply natin yan sa negative epsilon less than y sub n minus L less than epsilon. Mas accurate yan. Okay? Bakit? Kasi imposible naman na mag-equal yung y sub n minus L dito sa ating negative epsilon tsaka sa positive epsilon. Kasi unang-una, itong x sub n minus L ay greater than na sa negative epsilon. So sigurado tayo na yung y sub n minus L ay greater than na dito sa negative epsilon. Okay? Then, ganun din sa same reason dito. So pwede nating tanggalin na lang to. Huwag na natin isama to sa proof. Okay? So yun yung dapat maingat din tayo sa paggamit ng ating less than symbol. Okay? Or less than or equal symbol. So pwede nating i-analyze yun. Okay? Now, i-apply natin dito yung property din ng absolute value. So this implies absolute value ng y sub n minus L is less than epsilon. Okay? And as you can see, ito yung target nating i-prove. Okay? So therefore, yung sequence ng y sub n is convergent and yung limit niyan y sub n as n approaches infinity is equal to L also, which is yung sinasabi ng squeeze theorem or sandwich theorem. So this is done. Okay? So next naman, i-apply natin yung sandwich theorem. Okay, so let's have our example. Show that limit of sine n over 2n as n approaches infinity is equal to 0. Okay? So for our proof, note that for all n element of set of natural numbers, basic knowledge lang ng trigonometry, negative 1 less than or equal sa sin n less than or equal sa 1. Okay? So, hindi lumalagpas sa negative 1 tsaka sa 1 ang ating sin n for any natural number n. Okay? So, basic knowledge lang yan ng trigonometry. So, this implies negative 1 over 2n less than or equal sa sin n over 2n less than or equal sa 1 over 2n. So, nag-divide lang ako both sides ng 2n. At kung mapapansin nyo, ang ginawa ko mula sa basic knowledge, nag-establish lang ako ng dalawang sequences na mas mababa or less than or equal dito, tsaka mas mataas or equal dito, which is ito kasi yung pinuprove natin, yung sin n over 2n, yung sequence na to. Okay? So, nakapag-establish ako ng dalawa. Tapos, ang goal ko dito, titignan ko yung limit nito, tapos titignan ko yung limit nito, dapat same. Okay? Kasi kapag pareho yung limit nung mas mababa tsaka yung mas mataas for all n or for all natural number n, so pwede nating ma-apply yung squeeze theorem or sandwich theorem. Okay? Now, so hanapin natin yung theorem na to. I mean yung limit nito ng sequence na yan. So limit ng negative 1 over 2n. So hindi ko na isusulat yung n approaches infinity. So understood na sa atin yan. So this is equal to limit ng negative 1 half times 1 over n. Okay? And this is equal sa limit. So operations ng limit yan, no? Yung multiplication. So limit ng negative 1 half times limit ng 1 over n. So na-prove na natin yung operation na yan. And what is limit of negative 1 half? So that is negative 1 half. Constant sequence yan eh. Okay? Times what is limit of 1 over n. So yung kapangyarihan ng prove natin kaninang theorem, n yung denominator. Ang exponent niya ay 1, which is positive. So ang limit nito ay 0. Okay? And what is negative 1 half times 0? This is 0. So, dapat mapakita naman natin yung limit nito ay 0 para ma-apply natin yung squeeze theorem. So, limit ng 1 over 2n, this is same lang naman, same process lang. Limit ng 1 half times 1 over n, this is equal sa limit, so wala na kasing space, ng 1 half times limit ng 1 over n. So, this is equal to constant sequence 1 half yan, times, same lang yan, this is 0. And what is 1 half times 0? That is 0. So, as you can see, yung limit ng sequence na to ay 0, yung limit ng sequence na to ay 0, at isa pa na dapat nating tandaan ay ito ay palaging true, yung inequalities na to, for all natural number n. So, dapat ganun siya para ma-apply natin yung squeeze theorem. Okay? So, by squeeze theorem, yung limit ng sin n over 2n as n approaches infinity is equal to 0. So, ganun lang siya kadali. So, kung mapapansin nyo, kaya natin ginagamit yung squeeze theorem kasi kung titignan natin dito, mukha siya mahirap dahil sine function ang ating given. Kaya ang ginawa natin, gumawa tayo o nag-establish tayo ng dalawang sequences na mas madali i-prove o ipakita yung limit. Hanapin yung limit, and which is ito yon, na dapat for all natural number n, tama yung equation na to, inequalities na to. Okay? Satisfied yung inequalities na to. At kapag nangyari yon, titignan natin yung limit nila, dapat same limit yan, yung mas mababa tsaka mas mataas. Then, kapag nangyari yon, pwede na natin i-apply yung squeeze theorem, which is ito. Ganun na lang siya kadali. Okay? So, meron nang tumutulong sa atin para ma-prove yung limit nito. yung nasa gitna. Okay? So, ganun lang kasimple i-apply yung squeeze theorem at ganun kalakas yung kapangyarihan ng squeeze theorem or sandwich theorem.